Good morning students. Last video we have discussed about the derivation of a ellipse and some terminologies like focal chord, latus rectum, etc. So let us discuss the various forms of an ellipse today. So here, if this A dash is the major axis and B dash is called the minor axis. So here the major axis is along x-axis, that is y equals to 0. Therefore, the length of the major axis is A dash is equals to 2A, and minor axis is y-axis. Minor axis is y-axis and length of the minor axis is B dash, which is equals to 2B. Therefore, this is A comma 0 minus A comma 0. This is 0 comma B. This is 0 comma minus B. Here the condition is A greater than B, because this is A and this is B. A is greater than B. Next. So what are these S and S dash? S dash are the foci. So the coordinates of foci are S AE comma 0 and S dash minus AE comma 0. Now this Z comma Z dash are the foot of the directrices. So this is A by E, this is AE comma 0, this is minus AE comma 0. So this is A by E comma 0, this is minus A by E comma 0. Therefore, the equations of the directrices are, so this line is parallel to y-axis. Any line which is parallel to y-axis is of the form x equals to k. So this is x is equals to A by E, and this is equals to x equals to minus A by E, this line. So x is equals to A by E and x is equals to minus A by E, or the equations of the directrices. What is the condition between A, B and E? B square is equals to A square into 1 minus E square. From this, E is equals to square root of A square minus B square by A square. So bigger square minus smaller square by bigger square. So this is the characteristics of this ellipse A greater than B. So what if the ellipse is of this form? This here A is less than B, because this is A comma 0, this is minus A comma 0. This is 0 comma B and this is 0 comma minus B. So here A is this much only, while B is greater than A. Otherwise A is less than B. So here the major axis major axis is along, what is the major axis now? The major axis is y axis. Why? Because the foci, the fixed points are lying on the y axis. That's why the major axis is y axis now, along y axis. So that is x equals to 0. So length of the major axis is BB dash, which is equals to 2B. So likewise, what is the minor axis? Here the minor axis is the x-axis, which is y equals to 0. This is x equals to 0. So length of the minor axis is a dash. This is equals to, this is a and this is a, totally 2a. And coordinates of foci are S dash. So here, since this is lying on the y axis, this is 0 comma BE and this is 0 comma minus BE. So that is equals to 0 comma plus or minus BE. Likewise, what is the equation of the directrices? Equation of the directrices is this now. So this is equals to, this line is parallel to x-axis. Any line which is parallel to x-axis is of the form y equals to k. So y is equals to plus or minus b by e. So here this is z dash and this is z. This is 0 comma b by e. This is 0 comma minus b by e. Now what are the length of the lattice rectum? Length of the lattice rectum is equals to 2a square by b, while we forgot to write here. What is the length of the lattice rectum here? 2b square by a. Let us write here. Length of the lattice rectum. What is the length of the lattice rectum? This is L dash. So this is b square by a, 2b square by a. This we have proved in the theorem. So, and what are the coordinates of the coordinates of the lattice rectum? This is AE comma b square by a. This is AE comma minus b square by a. That is AE comma plus or minus b square by a. Here, what is the coordinates of lattice rectum? Coordinates of lattice rectum, that is equals to L dash. This is equals to this. So this is L dash. So this is a square by b, comma, this is lying in first and second quadrant, plus plus minus plus. So this is minus a square by b, comma, be. This is a square by b comma minus be plus be. So this is equals to plus or minus a square by b comma be. And what is the condition here? What is the condition between among a, b and e? A square is equals to b square into 1 minus e square. Further, e is equals to square root of b square minus a square by b square is the condition for this. What if the center of the ellipse is not at the origin? Earlier, first two cases, we forgot to write the center. So, which is a greater than b, and for a less than b, the center C is 0, 0. That is, this is the ellipse and this ellipse. So, for both of them, the center is at the origin. Here also, the center is at the origin. So, now, what if the center of the ellipse is not at the origin? What if the center is shifted to some other point which is other than the origin without changing the actual direction of the coordinate axis? If we transform the axis, then what if the center of the ellipse is not at the origin? So if the center of the origin, center of the ellipse is shifted to other than the origin, that means it is subjected to transformation of axis. So earlier this was the origin and this was the ellipse. Now the origin is shifted to some other point here. So this origin is O dash is now this. Earlier C is this. Now C dash is this. Earlier C is origin 0, 0. Now it is shifted to C dash. What is C dash? H comma K. Now the new ellipse is this. Now the new ellipse is this. What happened is, without changing the actual direction of the coordinate axis, so this capital XX dash is parallel to small XX dash, and this YY dash, this Y dash, capital YY dash is parallel to small YY dash. Now this is the new ellipse, and this being the directrices. These two lines being the directrices, and this is S dash, foci, A dash, vertices of the ellipse, B dash, the ends of the minor axis, Z dash, or the ends of the foot of the directrices of S and S dash. So here the axis, the major axis is along parallel to, earlier major axis is along x axis. Here the major axis is along parallel to x axis. So that is y is equals to k. This any line which is parallel to x-axis is the form y equals to k. Now, the length of the major axis is here also 2a only, a dash. This a dash is equals to 2a, and minor axis is along. Now the minor axis is this. Earlier the minor axis is y axis, x equals to 0. Here x equals to h, and length of the minor axis is b dash is equals to 2b. Now, so coordinates of foci. So coordinates of foci are s is equals to, earlier s is, this is a e comma 0, this is minus a e comma 0. So that means plus or minus a e comma 0 were the ends of the foci for the ellipse whose center is at the origin. Now here with x coordinate h will be added, with 0 k will be added. These are the ends of the foci. So here this is ae plus h comma k. Here this is minus ae plus h comma k. Okay, and so equation of the directrices. Equation of the directrices, or earlier this line, this is the equation of the directrix. Any line which is parallel to y axis is of the form x equals to something. So x is equals to, this is a by e comma 0, this is minus a by e comma 0, or the foot of the directrices when the center is at the origin. But here this line is also the parallel to y axis, therefore it is of the form x is equals to plus or minus ae plus h,
plus or minus a by e plus h.
Length of the lattice rectum. Length of the lattice rectum is equals to 2b square by a. In length there won't be any change. So now this is L dash. So earlier this is ae comma b square by a. This is ae comma minus b square by a. For this ae, h will be added. For this minus b square by a, k will be added. So this is ends of the lattice rectum. Ends of the lattice rectum is equals to L comma L dash is equals to AE. With AE, h will be added, h plus comma b square by a plus or minus b square by a, plus b square by a for this and minus b square by a for this, plus k would be added additionally. So these are the features of the parabola a greater than b, where the center is other than the origin, not at the origin. And the eccentricity is E is equals to square root of a square minus b square by a square, because a is greater than b case here. So now, and what is the equation of this ellipse? equation of this ellipse is x minus h whole square by a square plus y minus k whole square by b square equals to 1. For the ellipse whose center is not at the origin and a is less than b. So let the origin be shifted to some other point which is h comma k. So a is less than b and center is shifted to c is shifted to h comma k. Then so let us suppose that this is the coordinate axis. So this being the origin 0 0, this is x dash and this is y dash. So now without changing the actual direction of the coordinate axis, so if capital x dash is parallel to small x dash, so that is this. So this is capital x dash, and without changing the y axis, so the new y axis is this, and this y is this new axis is y dash, and this is parallel to the old y axis, small y dash. Now this is the center of the ellipse which is h comma k. Now the ellipse is this now. The ellipse is this. This is our new ellipse. Now this being the these two lines are the directrices. So here this s dash, a dash, so this is b dash, this is a comma 0, and this is minus a comma 0, this is 0 comma b, and this is 0 comma minus b. So the equation of this ellipse is, equation of this ellipse when a is less than b is x minus h whole square by a square plus y minus k whole square by b square equals to 1. Now here center C is equals to h comma k other than the origin. So now major axis is along, this is the major axis. When the center is at the origin, this y axis is x equals to 0. Here along x equals to h. So length of the major axis is b dash is equals to 2b. Next, minor axis is along y is equals to k. Length of the minor axis is a dash is equals to 2a. Next, coordinates of foci are s comma s dash is equals to, this is 0 comma be, this is 0 comma minus be, for the ellipse whose center is at the origin, but here with 0 h will be added and with be k will be added. That is, this is h comma be plus k. This is h comma minus be plus k. So this is equals to h comma be plus k and h comma minus be plus k. Now, so equation of the directrices. For this equation of the directrices, this is for the ellipse whose center is at the origin. This is parallel to x-axis of the form y equals to something. Here y is equals to this or z and z dash. So this is 0 comma plus be. This is 0 comma minus be. For the center is at the origin, but here with 0 h will be added. For this k will be added. So this is h comma this is minus be plus k. Now, since this is parallel to x-axis, y is equals to something, so this is equals to y is equals to plus or minus be plus k. That is, y is equals to be plus k. Y is equals to, this is y is equals to be plus k. This is y is equals to minus be plus k.
b by e plus k.
And length of the latus rectum. Length of the latus rectum is equals to 2a square by b. 2a square by b. So length of the latus rectum is this. This is L dash L, and this is also the latus rectum end. So this is M dash. Now, what is the condition among A, B and E? So the condition is A square is equals to B square into 1 minus E square. So therefore the eccentricity E is B square minus A square by B square. So this is the eccentricity when A is less than B. Now let us discuss the auxiliary circle. So this is the auxiliary circle. The auxiliary circle is defined to be the circle described on the major axis of the ellipse as a diameter. So the circle described on the major axis of the ellipse as a diameter is called the auxiliary circle. So this circle is formed on the major axis of the ellipse. Here A dash is the major axis of the ellipse and B dash are the minor axis, and this circle is formed based on this diameter of this major axis of the ellipse as the diameter. Therefore this circle is called the auxiliary circle. Now let us take P. Be any point on the ellipse P. So draw a perpendicular PN. Draw a perpendicular PN on the major axis of the ellipse. let P be any point on the ellipse and draw a perpendicular PN on the major axis of the ellipse and produce PN to meet the auxiliary circle at Q. So this point. Now, so this is our x-axis. So x dash. Here x, this is the center of the ellipse, which is 0 0 origin. So here angle ACQ is equals to theta, is called the eccentric angle. This P, you start with A and move this P in an anti-clockwise direction and again reach to A, then this complete revolution is 360 degrees. Therefore, this theta is lying in between 0 and 2 pi. So therefore, this theta is said to be the eccentric angle ACQ. Now you take triangle CNQ. CNQ. This triangle you take. This is C, this is N, and this is Q. So that is equals to, this is angle theta. Now from this, what is cos theta? Adjacent side by hypotenuse. This is CQ. So this is equals to, cos theta is equals to Cn by, what is Cn? If this is P x comma y, this Cn is x and this Pn is y. So Cn is x by CQ is the radius of the auxiliary circle. This is A, then this is also A, this is also A. So x by A. So this is equals to, x equals to A cos theta. Since this P lies on the ellipse, since P lies on the ellipse, x square by A square plus y square by B square equals to 1. This implies the value of x is A cos theta. Substitute in this. A cos theta whole square. A square cos square theta by A square plus y square by B square is equals to 1. A square gets cancelled. This is equals to y square by B square is equals to 1 minus cos square theta. This is equals to y square by B square is equals to 1 minus cos square theta is sin square theta. So y square equals to B square sin square theta. Therefore, y is equals to plus or minus B sin theta. Therefore, x comma y is equals to, since this is lying on the first quadrant, therefore this is B sin theta only. So A cos theta comma B sin theta. So the point A cos theta comma B sin theta, if you substitute in the equation of the ellipse, that is A square cos square theta by A square plus B square sin square theta by B square, then B square cancel, A square cancel. Cos square theta plus sin square theta equals to 1. This equation satisfies. So if you substitute this point in the equation of the ellipse, here equation of the ellipse gets satisfied by substituting this point. A cos theta comma B sin theta is said to be the parametric point. So A cos theta comma B sin theta, this is said to be parametric point. And x equals to A cos theta, y equals to B sin theta are said to be the parametric equations of the ellipse. Thank you.